All right, so this is the paper for today. 2019 theory questions. This question is about the structure of atoms and ions. Okay, can you tell me what the primary difference in atom and ion? What's the main difference in atom and ion?
Ion has charge.
Ions are charged and atoms are uncharged. Good. Then ions can have multiple atoms in them. Can you think of an ion with multiple atoms? Nitrate, phosphate, sulfate, carbonate. All of these are called molecular ions. They all have multiple atoms in them. But atom में तो एक ही होगा. What do we call atoms with different masses? What do we call atoms with different masses? So if you're thinking isotope, then that is not entirely correct. Because atoms with different masses can also be atoms of different elements. So we don't have a term for that. They're just different elements. But atoms with same proton number but different masses, those are isotopes. Puri baat zaruri hai. All right, so define the term proton number. Easiest definition that they could ever ask. Proton number is the number of protons. Baat khatam. Mazak hai. But koi nahi chalta hai. All right, so number of protons, but it's a 2-mark question. दो marks तो नहीं हो सकते number of protons के. तो फिर हम थोड़ी सी extra detail लिख देते हैं. That number of protons in nucleus of the atom. क्योंकि कुछ तो लिखना है. 2 marks हैं. All right, complete the table to show the number of proton, neutron, and electron present in atoms. Okay, so number of proton is the proton number is the smaller number, so 12 दोनों में. Okay, neutron is the difference in these two numbers, so 12 and 14. And because they're both neutral, number of electrons is same as number of protons. Our equation is proton minus electron gives me charge. So अगर कहीं पे mismatch आ जाता है, we can use this equation. What term is used to describe atoms of same element, such as this? These are isotopes. This is what you were talking about. Explain why chemical properties of these are the same. जी बताएंगे, chemical properties, what do they depend on? Chemical properties depend on valence electrons. If they have the same number of valence electrons, they will have same chemical properties. So we can say they have same number of valence electrons. Or if you don't want to use the word valence, then you can also say that instead of using valence, you can say electrons in last shell. You can explain that as well. But both of them are acceptable. Complete the table to identify the atoms and ions which have the following numbers. So first of all, how do we identify the element from the proton number? So 4 is beryllium in the periodic table, so I'll write Be. 17 is, if I'm not wrong, is it bromine? Can you please check? No, 17 is chlorine. Chlorine. Yep. And the numbers, okay, let's see. So number of electrons in beryllium is the same, 4 and 4. So 0 is the charge. 4 is the proton number and 9 is the nucleon number because you're adding these two. Similarly, for this one, 37 is the nucleon number, 17 is the proton number, and the difference, there is a difference in electron and proton, so this is going to be negative. Okay. Okay. State the electronic structure of the following atom and ion. So look in the periodic table. Where's aluminium? Aluminium has what? 3 electrons? 13, sorry. So 2, 8, 3. And sulfide. So sulfide 2 negative. That means I have to write configuration if I move 2 steps forward because it is 2 negative. So in the periodic table, there is sulfur, then there is bromine, and then there is there's sulfur, then chlorine, then argon. So because argon is 2 steps forward, I have to write configuration not of sulfur but of argon. So this is 2, 8, 8. Do you all understand this? -2 means you have to write the configuration 2 steps further. Positive means you have to write 2 steps back. That's how these work. Okay. Okay, the table shows the properties of elements in group 2. Okay, explain why element 2 have similar chemical properties. ये एक तरह से क्वेश्चन रिपीट हो गया. We just talked about that electrons that are the same in the valence shell, they have the same chemical properties. He is asking the same thing again, but just asking about group 2. In the previous question, it was a general question. Here, the question is about group 2 in particular. So we will say group 2 has the same chemical properties because group 2 have the same electrons. But which electrons? 2 electrons. So do not use any term that you're not sure of in the whole exam. If you're not sure what the term means, don't use it. आपको लग रहा है कि दो चीजें आइसोटोप्स हैं, कंफर्म कर लें. अगर लग रहा है ना कि नहीं यार पता नहीं आइसोटोप है या नहीं है, तो एक्सप्लेन कर दो दैट दे हैव डिफरेंट मास बट सेम प्रोटॉन्स. आपको याद नहीं आ रहा ना, कि तो याद आना चाहिए, बट लेट्स सपोज यू डोंट रिमेंबर दिस, then don't use a term without being sure of what that term means. For example, over here, they have similar chemical properties. अब कोई कहता है wait a minute, मैंने ऑर्गेनिक में पढ़ा था similar chemical properties homologous series की होती हैं, तो हम यहाँ लिख देते हैं they are in the same homologous series. तो बात गलत हो जाएगी. क्यों? Because they are in group 2, they are elements. homologous series तो compounds की होती थी, वो भी ऑर्गेनिक की होती थी, तो यहाँ पे नहीं लिख देना वो. So why do they have similar chemical properties? अब इसका बेसिक सा आंसर तो ये बनता है they're in the same group, but it doesn't explain it. To explain, I have to mention that they have the same number of valence electrons. But वो तो कोई भी चीज के लिए कह सकता था. This one is saying about group 2, so we'll say they all have 2 electrons in last shell. This 2 is making the question very specific. I am giving a specific answer here. Okay, explain why it is easier to predict the atomic radius of radium than the melting point. Let's see. What is easy to predict? Anything with a pattern. That's easy to predict. What's hard to predict? Things that don't have a clear-cut pattern. Okay? Those are hard to predict. So let's see. Atomic radius increasing, 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 increasing. करेक्ट ट्रेंड चल रहा है, और डिफरेंस भी कुछ ज्यादा नहीं है, 40 के करीब का डिफरेंस है, 30 to 40 का डिफरेंस है. यहां पे क्या हो रहा है? डिक्रीज, इंक्रीज, डिक्रीज, फर्दर डिक्रीज. सो द ट्रेंड इज नॉट कंसिस्टेंट. So it's easier to predict atomic radius because it is always increasing था ना? हाँ, it was always increasing, but the melting point it does not have a fixed trend. It's increasing and decreasing. So आप लिख सकते हो उसको. It's a one-mark question, so one of these things will be right. या आप लिख दो atomic radius is increasing, it has a fixed trend of increasing. You have to specify what trend. Don't just say it has a fixed trend. Tell me what trend it has. It's always increasing. Melting point does not have a fixed trend. Not enough. Tell me what trend you're talking about. It goes up and down. It increases then decreases. It has an erratic behavior because of that, but we have to explain it. Write the electronic configuration of magnesium ion. I've already explained to you that how do you write configurations? By looking at elements in the periodic table. So this is magnesium 2+. That means you move 2 steps back. So when you go 2 steps back from magnesium, you end up at neon. So that's going to be neon's configurations, 2,8. Don't write magnesium's configuration. Make a note of this. If it is positive 2, that means go 2 steps back and write wo wali configuration. If it is negative 2, go 2 steps further and write wo wali configuration. ठीक है, magnesium 2 negative आ जाता, so we would write configuration of what's 2 steps further? Silicon, if I'm not wrong. Okay. Magnesium is produced by electrolysis of molten magnesium chloride. Okay. So it is molten, so pretty straightforward. Case 1 of electrolysis. Construct equation for this. Negative electrode, magnesium 2 positive, Cl1 negative. These are the 2 ions that I have. So obviously at the negative electrode, I'm going to get magnesium. So magnesium goes there and it has to become magnesium. Remember this. In electrolysis at the cathode or anode, you're getting elements. Okay. So this is going to give me magnesium. How do you do that? By giving it 2 electrons. Okay. For chloride, This is going to give me chlorine. How does it do that? By losing 2 electrons. And I balance it. Okay. Magnesium reacts with aqueous copper 2 sulfate in redox reaction. Okay. क्यों नहीं करेगा reaction? मुझे बताएं, why does it react? Why does magnesium react with copper ions?
Higher in reactivity series.
Higher in reactivity series, it is more reactive. That's why, yes. So magnesium will obviously oxidize and copper will reduce. Which particle is reduced? The one that is going from higher value to lower values, copper. But don't say copper. Write copper ion or identify wo ion kaun se wala hai. Just saying copper is not enough because copper is a metal. Copper is an element. It's not a particle. Copper ion is the one that is being reduced. अगर आपने copper अकेला भी लिखना होता तो copper atom लिखते हैं. Copper खाली नहीं लिखते. And it's better to just write the formula. Explain the reason. Why is it reducing? Because it gains electrons. This one is gaining 2 electrons. Okay. Magnesium reacts with steam. Name the product. So in steam, we have H and OH. So magnesium is going to displace hydrogen there. Pretty straightforward. So it's going to produce magnesium hydroxide and hydrogen. But हमने एक चीज पढ़ी हुई है. Sorry, आप लोगों ने नहीं पढ़ी हुई. This is in A levels. So remember that with warm water or with steam, group 2 will produce oxides. With cold water, group 2 will produce hydroxides. This is a relatively new concept. Usually it's taught in periodic table or acid-basis salts. But if you studied acid-basis salts in grade 9, which was 3 years ago, it is possible कि आप लोगों को उस वक्त नहीं पढ़ाया था उन्होंने. Okay, so remember this, note it down somewhere. Group 2, when it reacts with steam, it produces oxides, and group 2, when it reacts with cold water, it produces hydroxides. So up magnesium will react with steam, producing magnesium oxide and hydrogen gas. Of course, they did not ask us for the equation. They asked us for naming them. So हम ये सारा सिर्फ अपने समझने के लिए लिख रहे थे. We'll delete it and we will write magnesium oxide and what? Hydrogen gas. Okay. All right. So tell me, if I take calcium and I react it with steam, what will I get? Name the products. So remember this, group 2 with steam produces oxide and hydrogen. So magnesium with steam produces magnesium oxide and hydrogen. Calcium with steam produces calcium oxide and hydrogen. Barium with steam, barium oxide and hydrogen. Okay, with cold water, they're going to produce hydroxide. So magnesium plus cold water, magnesium hydroxide and hydrogen. Calcium plus cold water, calcium hydroxide and hydrogen. Everybody clear on this? Say yes. अगर नहीं पता तो पूछें.
Sir, एक और दफा repeat करते हैं.
Sure, I'll send it in the group. I'll mention. So group 2 metal plus. Okay, so I've sent it in the group. That way you'll know. So over here I have calcium reacting with cold water. So calcium plus water gives me calcium hydroxide plus hydrogen gas. And of course you can balance this out. There you go. Okay, magnesium chloride is a soluble salt. Describe how a pure sample of magnesium chloride crystal can be made from magnesium. Magnesium chloride is a soluble salt. Every time you make salt, you have to know, is it soluble or is it snap? Two answers that you need to know. So this is soluble, but it is not snap. So what method should I use? The three methods of salt preparation we have talked about.
The acid plus base.
Very good. Acid plus base. Can we do acid plus metal?
Yes.
Yes, we can over here because this is not group one. But even if we do that, it wouldn't really help because it will create magnesium hydroxide and that will then react. So hum directly acid plus base kar lete hain. So what will you do? You'll take an acid. What is a good acid over here? I want to make a chloride. What would be a good acid?
HCl.
HCl, very good. What is the name of HCl? If I write this thing, HCl, what is the name of this thing?
Hydrochloric acid.
Or this may not be hydrochloric acid.
Hydrogen chloride.
Hydrogen chloride. What's the difference? If it has gas with it, it is hydrogen chloride, not hydrochloric acid. This is hydrogen chloride. This is hydrochloric acid. Remember this thing. Whenever they say hydrochloric acid, they mean aqueous. When they say hydrogen chloride, they mean gaseous. Okay. So I need acid, not the gaseous thing. So I'll take, add hydrochloric acid to what base? I could use magnesium hydroxide, I guess, or just magnesium. No, they're saying they can be made from magnesium. So हमें magnesium ही use करना है. So to magnesium. Okay. I have magnesium here. Tell me, should acid be in excess or should magnesium be in excess? Very good, Rabia. Magnesium should be in excess. The solid thing should be in excess because this is soluble salt. It will dissolve, so anything other than that dissolve should be limiting. Like hydrochloric acid is also soluble, so it should be limiting. So to add hydrochloric acid to excess magnesium in a conical flask, if you want to mention, लिखते हैं. Although उसने पूछा नहीं है हमसे. So the word excess is super important, okay? All right. Then obviously they'll react, mix them. ठीक है, mix कर लिया. Or mix या stir. हो गया जी. Then filter. Why? Because magnesium is going to be in excess, it's going to be left over. So you're going to take it out. Next step, we have the filtrate that we're interested in. So heat the filtrate. What do I heat it to? Do I heat it to constant mass or do I heat it to point of crystallization? Look at the question and then tell me.
Point of crystallization.
Point of crystallization. What word in the question tells you that that is required?
Crystals.
This word. Crystals. Yes, very good. Very good. So because we need crystals, that's why we have to heat it to point of crystallization. To point of crystallization. Then slowly cool. And that's how you make soluble salt that is not snap. Okay? All right. Zinc and copper are elements next to each other in the periodic table. Zinc is obtained from zinc blend. This is only a suitable question for people who study IGCSE. This part may not be relevant to people who take O levels. So what's happening here? Zinc blend is converted to zinc oxide. Okay, so that is called roasting. So we basically roast it so that it converts to zinc oxide. The way it occurs is oxidation. And it might be interesting even for people who take O levels, this equation. Look at this equation. So zinc blend is ZnS. I react it with oxygen. So when I react it with oxygen, I get zinc oxide and sulfur dioxide. Okay, so tell me, O levels people, what kind of reaction is this?
Oxidation.
This is oxidation and reduction. Always say redox, never say just oxidation. Okay, unless they ask you what is happening to zinc sulfide. So zinc sulfide is oxidized, but overall the reaction is always redox. What is being reduced here? It is oxygen itself, because notice that it has gained electrons here. So oxygen itself is being reduced, and zinc and sulfur are both oxidized. Okay, and how can we quickly identify? Is there a shortcut for us to know that this is a redox reaction? There is. Any equation that has an element is a redox reaction. So this has an element oxygen. Okay, then they're saying zinc oxide is converted to zinc in a blast furnace. We know in a blast furnace, you basically use a carbon and you reduce the thing with carbon. So you take zinc oxide and you put it in carbon. What will happen? Tell me.
It will get
Carbon
reduced.
being more reactive than zinc will react with oxygen. So it can produce carbon monoxide or carbon dioxide, one of the two, with zinc. So just balance it, I guess. Okay, is this displacement reaction? It is. Okay, why is carbon displacing zinc?
Sir, it is more reactive.
It is more reactive, very good. Okay, is this redox reaction?
Yes, sir.
Yes, very good, Umar. Yeah. And Aram, this is redox, and we can easily judge because carbon is an element and zinc is an element. And we also know that zinc is being reduced and carbon being oxidized. So yes, Aram, you're right about that. So this reaction is you basically add carbon, but we call it coke. Okay, that's a very pure form of carbon. And then we remove zinc. Interestingly, zinc is the only metal that you remove by distillation because it has a low boiling point. So we remove it through distillation. But again, IGCSE people need to know all of this, and O levels people can be asked about any of these. जैसे मैंने अभी आपसे क्वेश्चन पूछा. Name the alloy formed when zinc is mixed with copper. Come on, people, what is that alloy?
Brass.
Brass, yes. Okay, copper is a transition metal. It can have variable oxidation state, two other chemical properties that makes them different from group one. बहुत आसान सवाल है, multiple times आया है. So one is they have variable oxidation state. What is the second and third?
They are colored substances.
They have colored substances. Very good. So colorful compounds or colored compounds. And one more. High melting point, high density, better conductivity, they're all physical properties. None of them is chemical. The examiner is asking for a chemical property. So the chemical property of these things is that they can be used as catalysts. Again, because they have variable oxidation states. So they're colored because of variable oxidation states, and they have catalysts because of oxidation states. A compound of copper can be used to test for water. State the full name of this compound of water. Copper का कौन सा compound है which we use to test for water? बहुत आसान है. Come on. It goes white to blue.
Copper sulfate.
Copper 2 sulfate. Very good. Because the examiner is saying write the full name, we should write copper 2 sulfate. But copper 2 sulfate on its own is not enough. we need it to be white, and it is white if it is anhydrous. So anhydrous copper 2 sulfate. That is one. The other option is cobalt 2 chloride paper, which goes from blue to pink. And this one goes white to blue. Okay, potassium iodide reacts with this. Okay, reduce the charge, balance the equation. Okay, balance karna. Go on, everybody, give it a go. Try to balance this equation. So hope you're done. So here's how we can balance this out. I have 2 potassium, so I'll get 2 of this potassium on the left, which means I have 2 iodide, but this on this side I have 3 iodide, so I'll make that an even number. So because of that, I'll need 2 of this, which makes this 2, and because of this, that makes it 4. So of course, there are multiple ways of going about it. There's no fixed order. Reduce the charge on copper ion in CuI. Now I know that iodide is -1, it's group 7. So copper will be +1 to balance this out. So charge is +1. Don't say 1, +1. That's the answer. In terms of electron transfer, explain why copper is reduced in this reaction. Okay, so this is copper 2 sulfate. That means copper is +2. And over here, this is copper 1. That means it gained 1 electron, because you go from +2 to +1 by gaining an electron. Identify the reducing agent, potassium iodide. We know that. And if you want to be even more like give a even better answer, wo jo distinction वगैरह के लिए use होते हैं. So instead of saying potassium iodide, just write the iodide ion, because that is the thing that gives electron and reduces it. क्योंकि एक electron आया तो iodide नहीं दिया ना. So you can say potassium iodide, you can name it, you can even say iodide ion. By the way, what are the color changes here? Colorless to brown. Okay, remember this. There's one reducing agent in your syllabus, potassium iodide, goes colorless to brown. There's one oxidizing agent in your syllabus. That one is KMnO4, goes purple to colorless. Take care. Maybe I should make a sheet of all these short facts, colors, or that will help. Okay, what is the percentage by volume of nitrogen? 78%, right? Everybody knows this. IGCSE people write 79. Outline the separation of oxygen, nitrogen, and noble gases from liquid air. So first of all, what's the process called? Fractional distillation. That's the process. Okay, so fractional distillation is the process. What do? Because these are all gases already, we cool it. Okay, so we first get liquid air, but we already have liquid air. That's how उसने दे दी. So liquid air is heated, and substances with lower boiling point evaporate, yeah, are collected at the top at higher levels, and those with higher boiling point at lower levels. That's how you get it, right? So you have to just identify that this is based on boiling point, and the name is fractional distillation. It's a 3-mark question. State 1, large scale use of nitrogen. Nitrogen is used to make ammonia. Ammonia is used to make fertilizers. So you can write both of them. You can say it's used to make ammonia, or you can say used to make fertilizers. Name one gas that contributes to gas train. Don't say carbon dioxide. Sulfur dioxide, nitrogen dioxide. Those are the two gases. So SO2, NO2. Name them. They're asking us for name, not formula. So sulfur dioxide, that's good enough. Carbon dioxide, nitrogen dioxide is also good. State one environmental consequences of increasing percentage of carbon dioxide, global warming. If you're not talking about global warming, talk about its effect. Talk about how it melts the polar ice caps. Talk about how it will cause an increase in sea level. Okay. Similarly, when they say what is the environmental effect of acid rain, talk about how it damages the buildings, how it changes the pH of water bodies, how it changes the soil pH so crops can't grow properly. Describe the source of carbon monoxide in air. Incomplete combustion of carbon or carbon fuels. Okay, so incomplete. Don't say internal combustion engine, because that is where combustion happens. Okay, so incomplete combustion, that's the primary thing. Combustion of organic fuel, fossil fuel, or carbon waste fuel. It's better to say carbon waste fuel because they're specifically asking us about carbon monoxide. So carbon based compounds, that's good enough. Okay, sorry. Titanium is extracted from an ore called rutile. Rutile is an impure form of titanium 4 oxide. अब हमने कभी rutile को देखा नहीं, लेकिन हमें सारे क्वेश्चन आ जाएंगे इसके, अभी देख लेते हैं. Rutile is mixed with coke and heated in a furnace. Why are they doing this? Blast furnace का reaction क्यों कर रहे हैं? It's not blast furnace, just furnace. The reason they're doing this is because carbon is more reactive than titanium. That's why. Okay, the product is gaseous titanium 4 chloride. Okay, so obviously यहाँ पे क्या हुआ है? That titanium metal की बजाय titanium chloride आ गया. Obviously there might be a reason behind it. The gaseous titanium 4 chloride is condensed into liquid state. The titanium 4 chloride is then separated from liquid impurities. Okay. Suggest the name of the process by which liquid could be separated from liquid impurities. Liquid impurities. We just talked about it. What is the process called?
Fractional distillation.
Fractional distillation. Very good. Umar, your question is that can we write unburned hydrocarbons? No, we can't write unburned hydrocarbons because source of carbon monoxide is incomplete combustion, not unburned. Okay, so that's the name of the process. So yes, you're right, fractional distillation. Carbon monoxide is also produced in this reaction. Okay, why should carbon monoxide not be released? Because it is toxic, because it is poisonous, right? That is the reason it is toxic.
So can we say that it causes global warming?
Carbon monoxide does not cause global warming. Hydrocarbons produce global warming, or carbon dioxide causes global warming. This one causes blood cancer, and also it sickle cell anemia जो होता है, or it also causes respiratory issues and poisonous at the end of the day. Okay, this one's really easy. Moles hai. Let's do it. Relative molecular mass of TiO2. You just have to look it up in the periodic table. Ti की value क्या है? And oxygen to 16, and we know that. Let me open up periodic table. Okay, titanium. Where is it? Okay, titanium. Can't find it. Found it. Number 22. Okay, MR is 48. So 48 plus 32. That is going to be 80. Okay, number of moles of 400 grams of TiO2. So 400 mass hai, 80 MR hai, so it's going to be 5 moles. Okay, determine the number of moles of chlorine. So judging by the equation, if this is 1 mole, that is 2 moles. So this is 5 moles, that is 10 moles. Double ho raha na? Calculate the volume of chlorine that reacts with 400 grams. 400 grams of TiO2 is 5 moles, and volume of chlorine produced is 10 moles. So judging by that, that is 10 times 24, 240 TM3. Okay, so this is pretty straightforward question. काफी आसान था. Titanium 4 chloride is heated with an excess of magnesium and atmosphere balance the equation. Okay. I have 4 chlorine on the left, so 2 here, which means 2 here. Titanium 4 chloride can be reacted with sodium instead of magnesium. Okay, the reaction between titanium 4 chloride and sodium is similar to the reaction between titanium 4 chloride and magnesium. We already have the equation for magnesium. Write the chemical equation for titanium 4 chloride and sodium. So again, similar. I reacted with sodium, except sodium is going to produce NaCl, not NaCl2, plus titanium. The balancing equation is this. Suggest why the reaction is done in an atmosphere of argon and not in air. Why is that? You're heating it. Why do you need argon?
Sodium might react with the air.
No, this is not sodium, this is magnesium. Magnesium may react with air or may react with oxygen, or magnesium will burn, or argon is unreactive, it is inert. Any of those 4 answers would be fine. बात तो हम कर रहे हैं ना, सही बात कर रहे हैं. After titanium 4 chloride is heated with magnesium, the unreacted magnesium, where are they getting unreacted magnesium from? Question पढ़ के मुझे बताएं. Why are they getting unreacted magnesium? Read the first line and then tell me why.
Because there's an excess.
Yes, very good. It's in excess. This is the word. Okay. Very good, Rabia. Your answer is correct for the previous one. Okay. Dilute HCl also dissolves magnesium chloride. The dilute HCl does not react with titanium or dissolves it. Okay, that's good. अब क्या होगा? Give 2 observation and write equation for the reaction when dilute HCl reacts with magnesium. So that's easy. Displacement reaction होगा. Magnesium is more reactive than hydrogen ions, so you're going to get magnesium chloride and hydrogen gas. It's a gas, so I'm going to see bubbles, right? And magnesium is solid, so I'm going to see dissolve. So magnesium dissolves. Those are the observations. Every time I see gas, that is bubbles. There's a very weird word that they use for bubbles, effervescence. So you can write that as well. Name the process that you use to separate titanium from mixture after all the magnesium has been removed. सारा magnesium निकाल दिया. Magnesium अब हमारे पास mixture में है, solution में है. Okay? और टाइटेनियम को निकालना है, मैग्नीशियम क्लोराइड को लैदा करना है, टाइटेनियम को लैदा करना है. क्या करें? क्या करें? टाइटेनियम मेटल है, मैग्नीशियम क्लोराइड एक्वस है, कैसे लैदा करें?
Sir, titanium will not dissolve, right?
Yes, metal does not dissolve.
So
This metal, I mean.
can we use a magnet?
No, it's not magnetic.
Filtration.
Filtration, yes, perfect. You have a solid and a solution, so filtration is the answer. Titanium does not react with dilute acid or dissolvent. Explain why it does not react with dilute HCl. जी बताएं, क्यों react नहीं करेगी? कोई चीज टाइटेनियम मेटल है, HCl में डाला, रिएक्शन नहीं हुआ. क्यों नहीं हो रहा रिएक्शन? मैग्नीशियम कर रहा था.
It's less reactive.
And then hydrogen. Yes, Sumar, you're right. So yes, that was Rabia, right? So it is less reactive, but you have to specify what is less reactive than. So it is less reactive. So titanium less reactive than hydrogen. Why hydrogen and not chlorine? Because titanium makes a positive ion, hydrogen makes a positive ion. So they're going to displace each other if they could, but यहाँ पे तो नहीं होगा. Magnesium cannot be produced by electrolysis of magnesium chloride using inert electrodes. क्यों? Aqueous है. We just talked about it. Magnesium is more reactive than hydrogen. कैसे बनेगा? Hydrogen gas बनेगी. Name the product formed at the negative electrode during the electrolysis. Okay, let's see. I have aqueous magnesium chloride. So magnesium ion, chloride ion, hydroxide ions, H positive. And of course, the less reactive one goes on the left side. So that's hydrogen ion. And on the right side, I have chlorine. So it's going to be chlorine that goes on the other side. Okay, so it's easy. In halogens, if you have halogen, that is produced. If you don't, then oxygen is produced. Name the product formed at negative electrode. So that's going to be hydrogen gas. You have to name it, okay? The command word is name. Suggest how magnesium can be produced from magnesium chloride by electrolysis. So then you will obviously melt it and then do electrolysis. Don't use the aqueous part. That's the trouble. So use molten magnesium chloride for electrolysis. Okay. This question is about transition elements. Transition elements are harder and stronger than group 1 elements. Describe 2 other physical differences. Okay, this is really, really easy. Come on, tell me.
Colored, sir. Metals are colored.
That's not a physical property. It's a chemical property. Color and catalyst, variable oxidation state, these are 3 chemical properties.
Sir, they
Physical
have
में आपके
higher,
पास 3 है. Higher what?
higher melting points.
Higher melting point, yes. Higher density, better conductivity. These are 3 physical properties. So they have high melting point, high density. Okay.
Sir,
Yeah.
can we write about the malleability, or is that not a
Like,
part of
can you
physical
write that
properties?
they are that they do it more?
Like they're more easier to be shaped?
So the thing with that is that, for example, here, when we say high melting point, we are also implying that the other metals have low melting point, which is true for most metals. Group 1 metals, they have low melting point. Group 2 metals have relatively low melting point. So there's a contrast. There is a big difference there. But when you say they are better conductors, you're just saying that they are also conducting and they're good conductors. Magnesium is a good conductor. It's just better to use transition metals. So there's a less difference and more just a variation in that quality. They're doing the same thing, one is doing better. In this one is at one end, low melting point, and the other is at another end, high melting point, low density, high density. So that's a difference, okay, in group 1 and transition metals. Okay, state 1 physical properties that is similar. They're both conductors, they're both malleable, they're both ductile. This is similar. Sure, transition metals are better, but they're still, these qualities do exist in both groups of metals. Say 2 chemical properties, we talked about it. Colorful compounds, colorful ions, they have variable oxidation states or variable valencies, and they are catalysts. Cobalt is a transition metal, anhydrous cobalt 2 chloride is used for test for water. We recently talked about it. It goes from blue to pink. Iron is transition liquid. Which 2 substances react with iron to form rust? Come on, easy. बहुत आसान सवाल है.
H2O and oxygen.
Yes, water and oxygen. So water and oxygen. Now, because they did not ask us to name it, they just said which 2 substances, we could use the formula or the name. Both of them are fine. Which metal is used to galvanize iron? Galvanization is a special name given to when you coat iron with zinc. Electrolysis के chapter में हमने पढ़ा हुआ. So this is not electrolysis, this is sacrificial protection. So redox electrolysis के अंदर इसके जिक्र होता है. So instead of plating, we just no, this is plating. This is a layer of zinc that is on top of iron. Okay, the hull of a ship is made from steel. Metal blocks are placed on the ship's hull to prevent rusting. Okay, this is sacrificial protection. Use your knowledge of reactivity states to explain why magnesium is suitable, copper is not suitable. जी बताएं. Why is magnesium suitable and why is copper not suitable? Give a reason for each.
Sir, a higher reactive metal should be used for the outer coat in sacrificial coating.
So, what are you saying? Are you saying magnesium is more reactive than iron? Are you saying that magnesium is more reactive than iron? Because if you are, then you're right. परेशान ही हो जाते हो.
नहीं
So
सर,
yeah,
DM कर
magnesium,
दिया.
magnesium is more reactive than iron, while copper is less reactive. I have to talk about both of them because the examiner has asked about both of them. It's a 2-mark question, so I can't just be like magnesium is more reactive. No. I have to make it clear that I'm talking about iron compared to these two. If you just say magnesium is more reactive, copper is less reactive, examiner तो ये भी समझ सकते हैं ना that you're saying magnesium is more reactive than copper. उसका क्या ताल्लुक है इससे? We have to specify that we are comparing it to iron. So write the full thing. Rust contains iron 3 oxide. Okay, but phosphoric acid can be used to remove rust. Okay, so we are just taking a phosphoric acid and iron 2 oxide. What is rust? Iron 2 oxide. Okay, so iron 2 oxide reacts with phosphoric acid. Okay, you might not have seen this, but that's fine because we can still do this. Why? Because we know that metal oxides can be amphoteric or basic, and this is acid. So this is going to be an acid-base reaction. So what happens when you take an oxide and you react it with an acid? You get water. And the rest of it is just combined together. So iron phosphate. So iron phosphate, iron 3 phosphate, because this is iron 3 oxide. So yeah, there you go. You will get 3 hydrogens. So yeah, 3 water. See, I'm sure this is might be the first time you're looking at rust as a base. Iron 3 phosphate is an insoluble salt. We just saw it. Suggest how formation of it prevents further rusting. Think about it. You formed iron 3 phosphate on the surface of the ship. So what will happen? This is insoluble. So it will create a layer. So ये ship है, उसकी यहाँ पे एक पतली सी layer आ जाएगी. And because of this layer, oxygen will not be able to come into contact with iron. So iron 3 phosphate, FePO4. Don't write the formula unless you're absolutely sure that that is correct. Write the name if you have any doubts. Forms a non-porous layer that doesn't allow iron to I think come into contact with oxygen or water or air. Okay, so I would suggest a section B, which is pretty straightforward. This is about organic that we've studied in the previous papers. So I would suggest you try to solve these. Oh, sorry, these are 3 questions. So try to solve these 3 questions on your own. And of course, if you have any problem, we can discuss in the group.